morning to all of you. And first of all, let me thank uh, Chris and Mathur Sahab and Satyakumar Sahab for inviting me here, and Elets as well for making all the arrangements. I really did not know that I am the chief guest of this function. I am not here really as the chairman of the technology mission for Indian Railways, which expired in 2022. I am here as a normal professor of engineering at IIT Kanpur, who is about to retire, so I need not be taken very seriously also. Uh, uh, First of all, I'm really happy that Chris has been able to put up a program which is so really well packed with technology. It is I participate in various conferences and workshops in Europe and USA and Australia and China, and the lineup here is really very impressive. It is on par and probably even better than many of the conferences, railway conferences that are held elsewhere in the globe. Uh, so they need to be congratulated on putting up on such a serious show on a topic which is really very important, IoT and cyber physical systems in railways and transportation sector. IoT and cyber physical systems can really take off in our country, and India can take the lead in the world if railways takes it up in the real earnest. When I started looking at this eGov magazine that has been launched, very first page, very first article of page 10, and brings out a point which was very succinctly hammered in by Mr. Mathur, and also in his first statement, and that is currently numerous CPS applications are running in the Indian Railways, but there is no common thread binding them together. There is no common thread binding them together. All the efforts are driven by individual efforts. The captured data is stored in different databases, hosted in various facilities and locations. And this is the crux of the problem. This is one of the major issues that is facing IoT systems and cyber physical systems, not just in railways, but I have also been associated with the Integrated Vehicle Health Management Program for our light combat aircraft, Mark II, and the advanced medium combat aircraft. There again, you have it's like a system of systems. Like the railway is a system of systems. I'll come back to this later. When we started our first project in the technology mission for Indian Railways, TMIR, in 2018, the program on cyber physical systems was launched by the Department of Science and Technology by the then Secretary, Professor Ashutosh Sharma. And the first project that was taken up was the one for railways, with the initiative taken by Mr. Rajesh Agarwal, who happened to be the member mechanical at that time, and prior to that he was the general manager of MCF Raebareli. That was Industry 4.0 application implementation in manufacturing, rail coach manufacturing in Indian Railways. That was the title of the project. The problem, nobody knew what Industry 4.0 really was, even in 2018. The problem that was identified was that we need to do monitoring of the machines in real time. We need to track the material in real time, and we need to track the human beings through human machine interfaces, HMIs, in real time, bring them onto the same platform, software and hardware platform, integrate it with ERP, existing ERP solutions, do necessary optimization for process planning, scheduling, and also monitor the health of the machinery and do quality control. This, in a nutshell, defined the entire project. We need to monitor the machines, we need to monitor, we need to track materials, we need to monitor human beings in real time, and the data to be transferred, not stored like as it is currently stored in various places in the railway organizations, including CRIS. Not stored, but to be transmitted in real time in an interactive manner on a unified platform. The problem with these machines is, and that is a universal problem, whether you talk of the smart coach or the shell shop in MCF Raebareli. You have a shop floor which has, say, 60 different machines. 40 of them are from Siemens. Then there would be about 20 Fanuc robots. There are machines from Heidenheim. There is instrumentation from Honeywell. Now, you have Siemens control systems which will not talk to Fanuc robots. Fanuc will not talk to Siemens. Siemens will not talk to Heidenheim. Heidenheim will not talk to Honeywell. Sometimes Siemens will not talk to Siemens itself. Similar is the problem in the smart coach project. You have 10 different dibbas with 10 different sensors from 10 different vendors. None of them talking to each other. Each of them sending data to UK, another one sending data to Malaysia, and the third one sending data to somewhere in Allahabad. Nobody knows where the real-time raw data is going. The raw data is not accessible to Indian Railways. The data belongs to Indian Railways. The vendors are not willing to give it to Railways. They want to give only processed information in the form of red, green, and yellow button. If the raw data is made available, then the systems can be scaled up, then the systems can be integrated. And the kind of integration that I am aiming at is, that would be real integration, is that the data from Kavach is transmitted in real time to CRIS on a platform that is owned entirely by Indian Railways, where that data can also be integrated from the data that is coming from the track management system. The data from the track management system, whether it is from the interlocking of points, from the signals, from the platform, should be interacting with the Kavach system. That is the kind of integration which is required. Even in the light combat aircraft a few years ago, in Mark 1 of light combat aircraft, we had this problem that it again is a system of systems like the railways. You have the propulsion system, you have the landing gear, you have the hydraulic system, you have avionics, you have the electrical system, hydraulics, each with a large number of components, hundreds of components. and all of them sensorized. So it's a system of systems and large number of sensors, each coming from a different vendor. And these monitoring systems used to talk only to themselves. They used to process information and give information to the pilot in the form of a user interface where he just comes to know whether it is green, yellow, or red. That is all that he gets. It is not possible for me to transfer and see how the propulsion system is influencing the hydraulic system and the hydraulic system is influencing the landing gear. Unless I have that, I will not be able to build any kind of analytics. I will not be able to do any kind of safety analysis. I would not be able to do any kind of deep learning for optimization, and I cannot integrate it across the fields. So as I see, this is one major issue, that we need a platform, a hardware and software protocol which is indigenous and which belongs to Indian Railways, and it can definitely be housed in CRIS. This platform should be independent of the vendors, where the vendors can be allowed to come, plug and play their systems. They should be willing to contribute, they should be allowed to contribute. But the data should be transferred to the Indian Railways in its raw form as it is collected. Whether it is from Kavach, whether it is from machinery from Siemens or from Hygienine or from wherever it is. This platform needs to be standardized. So there is definitely a strong need, and I would advocate that a cyber physical platform should be launched at CRIS. A cyber physical platform for Indian Railways be launched at CRIS, which is ubiquitous, which is universal, where all the data from all the systems that we currently have on the railways is transmitted and processed. You have the capability to process it in real time. That should be possible. The other requirement is that with the data available, there is definitely a need to do and scope to do a lot of analytics. Analytics related to, as Mr. Bhatia said, about optimization of power requirement. There is already a proposal with Mr. Sudhir Kumar on power optimization on the lines of several railway systems in Europe, where the pain points of power consumption have been digitally identified, and power consumption has been brought down up to even 24 to 25%. This has been really done through analytics analytics with the data that is available from the sensors. So analytics can play a very important role. Analytics is required. Analytics will be path-breaking, and it is here that many of us can, not from the academy, and not just from the academia, but also from the industry, can play a very important role in providing analytics with the huge amount of data that is available with CRIS. Along with that, there are other projects in the area of IoT, and in fact, we are still not in the domain of IoT in the railways or in many other sectors. IoT would mean Internet of Things. when a thing starts talking to a thing. For example, uh, the glass of wine over there on that table would start noticing that the the bottle on the table is not a bottle of wine but a bottle of water, and does not communicate with the bottle of water but starts communicating with the bottle of wine which is there in the bar. It is Internet of Things. Things start communicating with things. The interlocking or the point machine starts talking to the train which is approaching it in a physical sense without intervention of a human being. That is Internet of Things. We are still not at that stage. We are at the stage of Internet of Thing and human being, or probably Internet of human beings and human beings, not at the level of Internet of Things. Several projects in this area need to be taken up. For example, Kavach itself needs to be strengthened, to be enhanced with the knowledge base that it currently has. I do not have detailed information about what kind of knowledge base on which it's operating, but there is a lot of real-time information that needs to form the knowledge base for Kavach. It may not be immediately possible because it may be prohibitively expensive with the kind of technology adopted. But very limited and restricted sensorization of tracks is very essential. If not all the 1.25 lakh kilometers of track, but at least 10 to 20,000 of track, which is very crucial, can be sensorized, especially at the points and at the crossings, at not very high cost. That sensorizations exercise for track management system, I would like to advocate that this needs to be taken up on a very, very high priority basis. And this data needs to be integrated with the data that is already on-board data that would be there on Kavach. Along with that, certain pilot projects on on-board monitoring of rolling stock need to be taken up for preventive maintenance and condition-based maintenance. This should drastically reduce the maintenance cost that is incurred by the Indian Railways. It has been adopted by several railway systems in Europe and has yielded good results. But the only issue is that the data should be under the control of Indian Railways. Whosoever supplies or provides the technology should provide real and raw data to Indian Railways. Onboard condition monitoring would include monitoring of bearings, monitoring of the condition of wheels, axles, suspension systems, couplers. I in fact started my journey with the railways through this project on Wild, which we developed at the cost of rupees 2.5 lakhs way back in 2003, 2004, and the demonstration was given to Mr. Nitish Kumar, and Atalji was the Prime Minister at that time in the Prime Minister's office. So, in the Prime Minister's office, we had Mr. Sudhindra Kulkarni, who also happened to be an IITian and a very close aide of Atalji. And we gave this demonstration, and then Atalji said, Nitish Kumar said that let us give this a form of a technology mission where projects are taken from a top-down approach, not that it comes from below. Some projects of national importance are identified from the top, and the national teams are formed. and then with the participation of the user industry, the academic institutions, and industry at the same time, with 20% of contribution coming from the industry, and the industry owns the technology. The technology is not owned by, data is owned by, should be owned by railways, but technology need not necessarily be owned by the railways. So technology is owned by the private industry, and the private industry would make profit out of it. So we did mention it to the Prime Minister that the private industry is participating in this is the model which is being would be implemented through the Department of Science and Technology for the first time, and industry will make money, मुनाफा कमाएंगे. तो अटल जी ने इस टिपिकल स्टाइल सेड इस देश में मुनाफा कमाना अपराध नहीं है. So that is the model that needs to be followed, but followed with proper honesty and implemented with full honesty. That we need a consortium, as is there in other countries. We need an honest consortium of the user, the industry for implementation, and for out-of-box innovation from the academia. Unless all these three arms get together, the innovation in the country is not going to see the light of the day, whether it is the railway sector or whether it is the agro sector. So, with these words, that to summarize, we do need a unified hardware and software protocol and platform for IoT and cyber physical systems in Indian Railways. There is need for analytics, data-based analytics, data-driven systems, digital twins, and deep learning technologies to be implemented with the information that we have in Indian Railways. There are a couple of important projects, crucial projects, which need to be taken up for implementation of IoT for both tracks and rolling stocks in the country. And we need a consortium-based approach for taking this movement forward. So with these words, I thank you very much for the opportunity that you have given to me to express my views. Thank you very much.